Hello everyone, welcome back to my YouTube channel. In this video, I want to explain how to solve the first three questions from EJU Physics 2019 first session. You can check link on the description box below if you want to watch the solution for the other problem on this paper, or check my EJU playlist for another paper. Okay, let's start for the first question. As shown in the figure below, two thin uniform rods of negligible mass are joined together at right angle. So we have two thin uniform rods of negligible mass. This is those two rods joined together at a right angle. And then their lengths are L1 and L2. You can see from the diagram, this is L1 and then this is L2. A small ball of mass M1 is attached to the end of the rod of length L1. So there is a mass of M1 at the end of L1. And then another mass of M2 is attached to the end of the rod of length L2. Another mass M2 is attached to the rod with length L2. The rods are suspended by using a string attached to their joint and come to rest. So the system is at rest. The angle formed between the rod of length L1 and the vertical in the downward direction is theta. So they let us know the angle between L1 and the vertical is theta. And then the question is, what is tan theta? They ask to find tan theta. First of all, in this question, I think we have to analyze the free body diagram of the system first. Since I have M1 and M2 here, so I can draw the weight of M1 and M2. The direction of weight is vertically downward. This is W1, let's say, and then we have this is W1, yeah, and then we have weight of M2. This is W2. And then since this system is in equilibrium, so the net force must be equal to 0, and then the net torque, which is moment of force, must equals to 0. I think since we do not know the tension on the string, I will use net torque instead of net force. So to solve this question, I will use net torque is equals to 0. I will consider this point as a pivot. Let's say this is A. So assume A as a pivot. The formula of torque or moment of force is force times perpendicular distance. This is the formula of torque. Force times perpendicular distance. So the distance between force and the pivot must be perpendicular. So we cannot simply write down moment of W1, let's say, as W1 times L1. We cannot write down like that because W1 and L1 is not perpendicular. So we have to find the force which is perpendicular to L1. How to find the force which perpendicular to L1? The answer is we have to resolve W1 and so W2, because W2 and L2 is not perpendicular each other. So I will resolve W1 if I assume the rod here has an axis. So this is the other axis. Our axis must be perpendicular each other, yeah. So these two axes are perpendicular each other. So if I resolve W1, I will obtain this one and this one. The one that is perpendicular to L1 is this component. So I will focus to find this component. I need this one. And then for W2, by using the same concept, I will assume that this is the axis. Remember that the axis must be perpendicular each other, yeah? And then this is W2. If I resolve W2, I will get these two components. The one that we need is this one, because this component is perpendicular with L2. So I will focus to find this component. Now, the next question is how to find this component. The answer is, we should analyze the angle. If this is theta, so I can say that this is also theta, because we can say this is a corresponding angle. So we have the same line and then we have the same vertical line. If this is theta, then this angle is also theta. So I know that this is theta. If you have theta here, then this one is W sin theta. This one is W cos theta. The component that makes the angle is cos, and then the other component must be sin. So since this component makes the angle, then this is W1 cos theta. That means this one is W1 sin theta. So I already know that this is W1 sin theta. And then by using the same formula, if I assume this angle as alpha, that means this is also alpha. This angle is also alpha. And then this component that makes the angle is W2 cos alpha. That means the other component is W sin alpha. So this component is W2 sin alpha. W2 sin alpha. And then since the system is in equilibrium, then the net torque about pivot A must equal to 0. You can see that W1 sin theta will produce counterclockwise moment, and W2 sin alpha will produce clockwise moment. So that means if I assume counterclockwise to be positive, then the clockwise one is negative. So W1 sin theta times L1, I assume counterclockwise is positive direction. W1 sin theta times L1 minus, since this is clockwise direction, so is counterclockwise is positive, that means the clockwise one must be negative. Minus W2 sin alpha L2 is equals to 0. If I move W2 sin alpha L2 to the other side, I will get W1 sin theta L1 equals to W2 sin alpha L2. And then W is the weight of an object. The formula of weight is mass times acceleration of free fall, or mass times gravity. So I can change W1 into m1g sine theta times L1 equals to W2 is m2 times gravity sine alpha L2. Of course, I can cancel out the gravity here. Then we have to find sin alpha. What is the relation between alpha and theta? If you see from this diagram, theta plus alpha must equal to 90 degree. So sin alpha is equals to 90 degree minus theta. So our equation becomes m1 sin theta L1 is equals to m2 sin 90 degree minus theta. Let me write down here, yeah. So from this row we continue to that one. 90 degree minus theta times L2. And then, as you know, sin 90 minus theta becomes cos theta. So I got m1 sin theta L1 is equals to m2 cos theta L2. You can use compound angle identity to prove that sin 90 minus theta is equals to cos theta. And then last but not least, if I move cos theta to the left hand side, it becomes division. I will get sin theta over cos theta is equals to, I will move m1 and L1 to the other side. It also becomes division. Then I will get m2 L2 over m1 L1. As you know, sin theta over cos theta becomes tan theta. So tan theta is equals to m2 L2 over m1 L1. So my answer for the first question is number 2, m2 L2 over m1 L1. Okay, let's proceed to the next question. As shown in the figure below, a small ball is thrown with initial speed VO. We have a small ball here, and this ball is thrown with an initial speed VO from height h above a horizontal floor in a downward direction, forming an angle of 45 degree with horizontal. So this is our ball, and then we will throw this ball at a speed or initial speed VO from a height h and with an angle 45 degree to the horizontal. The ball lands on the floor at a position that is horizontal distance h over 2. So the horizontal distance for which the ball is landing is h over 2 from the position the ball was thrown. So after we thrown the ball, it will land here with a horizontal distance h over 2. And then the question is, what is VO? We want to find the initial speed of the ball. For this question, we can say that we have a projectile motion or parabolic motion. For a parabolic or projectile motion, we have to analyze in both x or horizontal and y or vertical axis. For horizontal axis or x direction, there is no acceleration acting on the ball for the horizontal axis. And then for the vertical direction or vertical axis, there is a constant acceleration acting on the ball, which is gravity. So the one that we should remember for projectile or parabolic motion is in horizontal component, there is no acceleration, and then in vertical component, there is a constant acceleration, which is gravity. First of all, I will try to analyze the horizontal direction first. So let's focus on horizontal component. Since I focus on the horizontal component, then VO must be resolved to the horizontal component. So instead of VO, I need this one, the horizontal component of the velocity. Since this component makes angle 45, that means this is VO cos 45. And then, since for horizontal component there is no acceleration, so our equation is distance is equals to speed times time. Distance is equals to speed times time. You have to remember, we are talking about horizontal component. So when I say distance here, we should see the horizontal distance, which is h over 2. So horizontal distance is h over 2 is equals to horizontal speed, which is VO cos 45 degree times t. This is what we get from the horizontal component. And then let's move to the vertical component, because we cannot do anything about this equation. We still do not know h, we still do not know time. So I will move to the vertical component. For the vertical component, there is acceleration which is equals to acceleration of free fall or gravity, which is g. Since there is an acceleration, so the equation that I can use to analyze the vertical component is distance equals to initial speed times t plus half AD square. This distance is the vertical distance. Vertical distance is h. This initial speed is the initial speed in vertical direction, which is this one. So we need to find this one first, the vertical component of the speed. Since the horizontal component is cos, then the vertical one should be sine. This is VO sine 45. So h is equals to initial speed in vertical direction, which is VO sine 45 degree, times t. Remember, we still do not know the value of t, so leave it as t, plus half a, our acceleration is gravity, and then our motion is in the same direction with gravity. Our ball or our object is moved downward, and then the gravity is also downward. That means our motion is accelerated. Since it is accelerated, then the sign here should be positive. Half gt squared. This is our analysis in vertical component. Last thing that we should do is we have to combine these two equations to find VO and to eliminate t. We do not need time in our final answer. So I need to eliminate time. How to eliminate time? If you see from these two equations, I think I can write it down as VO cos 45 times t is the same as VO sine 45 times t. Because as you know, cos 45 is equals to sin 45, which is half square root of 2. So first of all, I will substitute VO cos 45, which is the same as VO sin 45, I will change this expression becomes h over 2. So I will get h equals to h over 2 plus half gt squared. And then if you move this to the left hand side, h minus h over 2 is h over 2 is equals to half gt squared. And then I can cancel out 2 down here. Then I will get h equals to gt squared. And then last thing that I have is t is equals to square root of h over g. T is equals to square root of h over g. And then since I want to find VO, I can substitute the time here into either this expression or this expression. I think we can substitute it into either this one or this one. Let's try to substitute it into this expression first. I will get, we want to change the t here becomes square root h over g, yeah? So I will get h over 2 is equals to VO cos 45 degree times t is square root h over g. And then if I square both sides to get rid the square root here, I will get h square over 4 is equals to VO square cos square 45 degree times h over g, and then cancel 1h here. Then cross multiply g to the left hand side, then I will get hg over 4 is equals to VO square cos square 45 degree. Cos 45 is equals to half root 2. Half root 2 being squared is 2 over 4, which is half, yeah? So cos square 45 degree is half. And then we can cancel out 2 and 4 here, leaving 2 on the left hand side. Then I get VO is equals to square root of GH over 2. Square root GH over 2. We still have not find the answer, so I think I will manipulate this expression first. I will rationalize the denominator by multiplying it with square root over 2 over square root over 2. Then I will get square root of 2gh over 2. So my final answer for question 2 is number 2. Square root 2gh over 2. Okay, this is for question number 2. Let's proceed to the question number 3. As shown in figure 1 below, a small object is gently placed on the slope that has friction and forms angle theta with the horizontal. So our surface or our slope has friction and then makes an angle theta with horizontal. And it begins sliding down with uniform acceleration. Let us denote A as magnitude of the object acceleration in this case. And then next, as shown in figure 2, an initial speed is applied to the same object in the upward direction. We give this object an initial speed, and then this object will move in upward direction, causing it to move up the same slope. So we have the same slope, That means we have the same angle and the same frictional force with uniform acceleration. And then let us denote as A prime the magnitude of the object's acceleration in this case. So the acceleration of the first figure is A, and then the second, or the acceleration of the object on the next figure is A prime. And then the question is, what is A prime? We want to find acceleration for the second figure, and then we have to express it in terms of A, which is the acceleration of the first figure. Okay, first of all, I will analyze the first figure first. Let us analyze this one. We have weight here. Weight is always vertically downward. I have weight here. And then the component of weight that is down the slope is mg sin theta. So this one is mg sin theta. This is the component of weight down the slope. You can analyze the angle, yeah, if you want to know why this is mg sin theta. Since there is friction between the object and the surface, so I have friction here. Friction will opposes the motion. Since the object moves down the slope, then the friction is going up. This is frictional force. This is the only forces, these two forces is the only force that acts in the same direction to the motion. So, if I use Newton's second law, net force is equals to m times A. So, I have mg sin theta minus f because the direction of motion is going down. So, mg sin theta is positive direction and then f is negative direction. So I have mg sin theta minus f is equals to m times A. Let's skip this equation. I still do not know how to apply this equation. So let's skip this equation first. And then for the second one, by using the same analysis, we have mg here. I have mg down this vertically downward. This is mg, and then if I resolve this mg, I will get one component down the slope, which is mg sin theta. So you have to remember, yeah, if you have an inclined plane and then you want to find the component of weight that is down the slope, it is always mg sin theta. Mg sin theta. And then since this object move since this object move upward, so the frictional force is going down. So instead of going up like the first figure, the frictional force acting on this second figure is going down, because the motion is going up. This is the frictional force. Once again, these two forces is the only force that acts in the same direction of motion. So by using Newton's first law, I got net force is equals to m times A. Be careful about the sign, yeah. The object moving downward, these two forces is down. So instead of positive, I should write down as negative mg sin theta minus f is equals to m times a prime. The acceleration is a prime. And then by combining these two equations, of course I want to eliminate the frictional force because our answer is independent of frictional force. So by eliminating the frictional force, I think I will get a prime. How to eliminate the frictional force? I will simply add these two equations. Just add it up. Then you can cancel out the frictional force here. Negative F plus F can be cancelled out. And then negative mg sin theta plus mg sin theta. Wait a second. Oh, sorry, yeah. This is negative, not positive. My bad. Wait a minute. This is negative mg sin theta minus f equals to ma. So instead of add it up, we have to subtract it. So negative f minus negative f becomes plus f, and it can cancels out, and I will get negative mg sin theta minus mg sin theta. I got negative 2mg sin theta is equals to ma prime minus ma. And then let's divide all the terms by m, so you can cancel out m here, here, and here. Cancel out all m, and we will get negative 2g sin theta is equals to a prime minus a. My final answer is a prime is equals to a minus 2g sin theta. If you see from the choices below, you cannot find a minus 2g sin theta, but don't be confused. Just factorize negative here, and then I will get 2g sin theta minus a. So I think the correct answer is number 4. Remember, a or acceleration is vector quantity. So if I want to find the magnitude, we can factorize the negative sign, and then we got 2g sin theta minus a. This is the magnitude of the acceleration. The negative sign here represents the direction. So we can say that acceleration or a prime is decelerate. So this object is deceleration instead of acceleration, because the direction of motion is going up, but the net force is going down. So I think my final answer for question number 3 is number 4. Okay, this is question number 3 and also the end of this video. Thank you very much for watching this video till the end. I hope I see you guys on my next video. Thank you and bye bye.